Now, before we understand microservices and the architecture of microservices, it's a time to understand some Docker basics. Just for your kind of information, microservices extensively use containerization, which is invented by Docker. And that's why let's try to deep dive into Docker first. And once you understand some terminologies of Docker, it will be really easy for you to understand microservices. So what is Docker? Well, actually, if you go to the official site, which is docker.com, you will get to know the official definition wise. Docker is nothing but a containerization platform which is used to develop, ship, and run containers. This is actually something which is helping you to develop, ship, and run containers. Now, obviously, if I want to understand this definition, I need to understand what is this container is all about. And that is something which I'm going to explain very soon right now. But before we do that thing, they also share some information like Docker doesn't use hypervisor, and you can run Docker on your desktop or laptop if you're developing and testing application. Yes, development of Docker is available in almost all the operating systems, and on your desktop or laptop you can install something which is known as Docker Desktop. And once you install that thing, you can also develop, ship, and run containers in your development environment. The desktop version of the Docker support Linux, Windows, and Mac OS, all three operating systems. And for production systems, you are going to use a Docker with some kind of server environments, which include many variants of Linux operating system, as well as Microsoft Windows Server 2016 onwards. Many clouds, including Microsoft Azure, supports Docker, and that's one of the reasons somewhere in this course we have Microsoft Azure also as a very important part of this curriculum. Now, as I said, Docker is a containerization platform. So to understand Docker, we need to understand what is container. A definition says that a container is a loosely isolated environment that allows us to build and run software packages. Now, these software packages are maybe those applications which you have developed. This packages includes the code and all the dependencies to run the applications quickly and reliably on any computing environment. This means that if you develop some application and there are some packages, there are some third-party libraries, there are maybe some other dependencies which are required to run that application. All of them you're going to package into one thing, and that package is actually known as image. So they are saying we call these packages container images. Remember guys, these all terms are very important. If you want to understand Docker, you need to know container. If you want to understand container, you need to understand that container is something which is based on a package called container images. This container images becomes a unit we use to distribute our application. So if I want to share my application with my team members, with my customers, with my clients, this is an image which I'm going to share it with them. Remember, this image is not something like a photo, it's actually a package. Hence, we can call this container as instance of image. Yes, of course, the official definition says that container is a loosely isolated environment, but I am always going to say that container is nothing but an instance of an image. Intentionally, I'm using the word instance. Why? Well, that's because this instance is something which is one running instance of your code. And that's why we are calling it instance of an image. Technically, cutting the long story into short, what Docker has done actually, when Docker is inventing this containerization platform, you know that every time we need to have a physical infrastructure first. On top of physical infrastructure, we are going to have operating system, which can be Linux or Windows. And then on top of that, we mostly use some kind of web server, app server, IIS server, or maybe Tomcat server you have used earlier in different kind of application deployments. In this case, inside of those web servers and app servers, we are going to take Docker, and that Docker is going to allow me to run my applications on top of that as a container. So remember, it's not directly application is running. Applications are actually wrapped up into something which is known as container, and that's why we are calling these applications containerized applications. If I want to conclude all these things, we have two important words in this, which is images and containers. If you ask me what is images, I'm going to say image is nothing but my application code which I have developed, plus all the dependencies which are required to run that. And the containers are nothing but instance based on those images, those packages. Remember, image is not a running thing. Container is a running thing. And that's why the containers are going to run on something which is a Docker host, the environment which is provided by the Docker. These dependencies can include packages, libraries, files which are required to run that application, and it can also include operating system. And it can also include operating system. Yes, there are chances some of the applications require operating system also. Then those operating system can also be a part of dependencies, and it can be added in your image. Now obviously if I'm going to add a full operating system in the image, the size of the image is going to be big, but that is also something which is possible, and we can still create that kind of bigger image and container from that. Because I'm saying containers are instance based on image, remember one thing: when you create one image, and from that one image, if you want to create multiple containers, it is 100% possible. Even there are chances that each container is going to have a different life cycle. Like maybe any one of you is a developer, then you know that when we create object of the class, we call it instance. In this case also, I'm calling it instance because my image is going to be one package using which I can create a running instances of my application, and those things are actually known as containers. So I can create maybe 2, maybe 3, maybe 30 containers from one image, and then each container is going to have a separate running life cycle. That's why I'm saying it's an instance based on an image. Once you understand this basic terminologies, now the next thing is we need to understand something which is known as architecture of Docker. Let's focus on that in the next video. Thank you. Okay, so now it's the time to understand Docker architecture. Now this architecture is actually going to explain that how Docker works and what kind of components are there inside the Docker. Let's have a look at it. This is something which is a Docker architecture, and you can see here we have two sections. Left side we have Docker Hub, and right side we have Docker Host. We need to understand both of them separately. First, if I talk about Docker Hub is something like a image repository. If you are a developer, I'm sure that you are familiar with the word called GitHub. Now, as we know, GitHub is something which is a code repository. Same way, Docker Hub is actually image repository where number of official images are available from Docker and various different organizations. As well as if you want to create your image and you want to put it on Docker, then Docker Hub is going to be the right place to put your images publicly or privately. And then your clients, your customers can pull those images and they can create containers from that. The right side part in this architecture is a Docker host. Docker host is actually that hosting environment where your containers are going to be created and running. That's why inside the Docker host we have multiple sections. We have something which is known as Docker engine, which is the main runtime engine responsible for running the Docker containers. And then inside that we have Docker server, Docker client, and in between them we have REST API. Let me tell you one thing, Docker client is just a command line interface. Even right now, if I want to give some instructions to Docker, I have to open PowerShell or command prompt, and then using the word Docker, I can fire various Docker commands. I can say Docker PS, I can say Docker images, I can say Docker run, I can say Docker pull or Docker push. All these are commands. In the next video, we're going to see some commands, but let me tell you one thing. Whenever you're going to fire any command, you're actually using Docker client. And Docker client is that command line interface which allows you to give your inputs and your instructions into Docker. Once you give that, there is an internal REST API. This REST API is going to take your commands and inputs, and according to that, it is going to send the request to Docker server. Docker server is the main part of this architecture because this server is responsible for taking care of all the container creations, all the image building process, and all the integrations which you are doing with the images from Docker Hub. Docker server is going to do all the work based on the instructions which you have given via REST API through Docker client. And then once that particular work is done, the request and the response is going to be taken care by REST API, which is going to be handled in Docker client and is going to be visible in Docker client as a response or output. You can see inside the Docker host also we have a section for images. You can pull the images from Docker Hub or any public repository which is available, and then you can push it and you can store it inside the local development or hosting environment. So images can be stored locally or it can be available globally on this kind of repositories. And then after that, you can just integrate all of this into one. This architecture shows me that ultimately Docker server is the one which is going to pull the images and then is going to run my containers. You can run multiple containers inside one Docker environment, and all of these containers are going to be running based on the Docker engine which is responsible for execution. This is explaining the same thing which I have mentioned earlier, but these terms are important for you to understand. So we have three important terms: Docker client, Docker server, and Docker Hub, which we are going to use again and again throughout this discussion. Once you understand that, you also need to understand two more terminologies: we have something which is known as host operating system, and we have something else which is known as container operating system. Let's understand this. The host operating system is the operating system on which Docker engine runs. Docker container running on Linux share the host operating system kernel and don't require a container operating system as long as the binary can access the operating system's kernel directly. This line is directly indicating that the operating system on which you have installed Docker or Docker desktop, that is an operating system which is treated as host operating system, because on this your Docker is going to run. Once you do that thing, you can see in the image Docker server is also visible, which is responsible for creating all the containers and making sure that it's going to be running fine in that. In this case, when you have containers, the containers are not going to have any operating system inside that. All the containers are going to run on the host operating system, and if they want to connect with the operating system kernel directly, they will be able to connect to it. So this diagram is showing me a Docker image which is not having any base operating system inside that. Actually, that operating system is known as container operating system, which we will see in the next slide. But remember, the host operating system is the one where Docker engine runs, while the other operating system, which we need to understand, is actually container operating system. The container operating system is the operating system that is part of the package image. As we already discussed earlier, that your image can have all the dependencies which are required to run your application, and maybe one of the dependency is an operating system. Now, if your operating system is a dependency of your application and you want to include that in the image or in the package which you are creating, then you can do that thing, and that operating system will be known as container operating system. We have a flexibility to include different versions of Linux and Windows in that, and then this flexibility allows you to access specific operating system features or install additional softwares in that. Think about this package or this one image which is having one operating system of specific versions of Linux or Windows in that. On top of that operating system, you have installed some softwares. On top of that, you are configuring certain things, and then you are running your applications with that. This combined package size is going to be really big because it's having a full base container operating system inside that. Even if you create something like this, and if you want to connect with the host operating system or the kernel of the host operating system, you can still be able to achieve that thing. And this diagram is showing you the same thing in this Docker image, which is having Ubuntu based operating system. It can be Windows, it can be Linux, it can be another one with the specific versions with that. But remember, container operating system can be having only Windows or Linux, not Mac. It is going to have either Windows or Linux versions inside the container operating system. And that's what container OS is all about.